All right. Today, we will study what we call subspace of Rn. So, what is basically a subspace? And then I'm gonna give you another term that we can compare against, which is a subset. So subset means if we have this the entire set or the universe, and simply the subset is just part of this universe, right? So if it is called A, then you guys know this, right? And so now, we apply this notion into the vector space or high dimensional space. So, for example, our U or the entire space is, for example, R3. So this is our entire space, and so any vector in three-dimensional space, for example, 1, 2, 3, and 0, 0, 1, minus 1, 2, 1, and so on. So any kind of vector is just a member or element of this universe set. And then you can think about the subset as something like this, right? So this is just a part of your entire set, okay? So this is a subset, but the title of this chapter is subspace. Okay, so what is a subspace, and what is the main difference of the subspace against the subset? Okay, so in the case of a subspace, you have to satisfy several additional constraints. So that given your subspace, which is basically, so subset is a kind of subset, okay? Subspace is a more strict concept, okay? So every subspace is a we call every subspace is just subset, okay? And then in order to become a subspace, the additional constraint that we have to satisfy is, so suppose we have 4 entries or 4 elements in our subset, and then you just pick any of the 2. Okay, so let's see. I'm gonna call these vectors as vector 1, vector 2, 3, and 4, and then you just randomly pick up. So you picked up 1 and 3, and then these are just 2 vectors. So for example, so this is the first vector, and then this is the second vector, and then you just form any kinds of linear combinations using these 2 vectors. So 1, 2, 3 times maybe 1 plus maybe 2 times minus 1, 2, 1. Okay, in that case, can you give the result? It's a minus 1, 6, and 5. Okay, so we form just one linear combination from these 2 seed vector that we picked up from our subspace, and then this vector should be included in our subspace A. So in that case, we call that as a subspace instead of just calling that as subset. So in other words, subspace should be closed under linear combination. Okay, so so you guys know the meaning of closed or open. So let me ask maybe some basic question. So let's think about z as all integer. So let me ask a few questions. This z containing all the possible integers, is it closed under addition? Or in Korean, what is it? Yeah, how do we say it in Korean? 닫혀 있다 혹은 열려 있다. So integer set is closed under addition. What about subtract? Is it closed? So you pick up any two entry from your set, and then you just subtract between them, and then you decide. Yeah, you see whether that entry is also included in this set. It's closed under subtraction. What about multiplication? Yes, right. What about the division? Division is not, it's not closed under division, right? So if we pick up 3 and 5, then the division of between these two will be 3 over 5. So this is not included in our set, right? So this is the notion of closed or open. Okay, so back to this vector subspace. The subspace should be closed under linear combination. Okay, then so what it means is actually, you pick up any two vector and then just linearly combine them using whatever linear combination coefficient, and that resulting vector should be included in our set. And so we actually studied a similar notion, that satisfies this condition. Can anyone give an answer? Let's start with the S group.